George Hearn is an associate professor of civil engineering at the University of Colorado Boulder. George Hearn has served as a principal investor for bridge-related projects sponsored by the National Science Foundation, the National Academies, the U.S. Federal Highway Association, and the state of Colorado. George Hearn is a member of the Federal Highway FHWA Expert Task Group for Bridge Preservation, member of the TRB Advisory Panel for Bridge Durability and the Long-Term Bridge Performance Program, chair of the TRB Committee AHD 30, Structures Maintenance, and academic director for the Western Bridge Preservation Partnership. George Hearn is a licensed professional engineer. So if you would please help me welcome George.
Afternoon. I'm very happy to be here. I'm happy to be invited. I'd like to present some things that I've worked on with the FHWA Expert Task Group for Bridge Preservation over the past several years. One of the things that that group, the Expert Task Group, has been interested in is performance measures, or our performance measures, I guess is the right way around. But in particular, how to measure preservation, how to measure what we should be preserving, how to measure the effectiveness of preservation, how to measure what's being accomplished in preservation of bridges. So some of this work is a few years old, but I kind of go over the history of where the group has gone. The ETG, the Expert Task Group, is headed these days by Raj Ailani. Previously, it was Anwar Ahmad, and there's a number of state DOT people. I see Dave sitting here is on the ETG, Jason too. Ed Welch is on the ETG. So a lot of folks who are busy in the regional preservation partnerships are busy in this FHWA group. And what I've been doing is presenting ideas for performance measures and getting feedback from the group, getting their response and their comments, and that's helped us, I think, make them a little bit better. So we got to get some definitions going. What's bridge preservation? Well, AASHTO had adopted a definition of bridge preservation back in 2011, and I broke it into bullet points because some of these we can measure or we've tried to measure. So bridge preservation is actions or strategies that prevent, delay, or reduce deterioration of bridges or elements, restore function of bridges, keep bridges in good condition, extend bridge life. And preservation actions may be preventive or condition driven. So maybe we can measure some of these things like extend bridge life, or certainly we can measure bridge conditions. You know, we can look at condition ratings and see if the bridges are in good condition or poor condition. We can measure maybe whether we're preventing or delaying deterioration. So we'd like to see what we can do in measuring those aspects of preservation as being performance. So here's some information we put together. This is around 2013. This table was generated for an older paper. So what performance measures are bridge owners using? We've got to kind of start from there to see what it might be reasonable to ask people to measure. There are several sources here. The MTKN is the Midwest Transportation Knowledge Network. So they put together a survey of performance measures. There's an NCHRP study that sent a survey to state DOTs and then asked them what they were measuring for bridges. There was an AASHTO roundtable, that was back in 2011. And a questionnaire from the ETG, Dave Juntanen did that, also in 2011. So we see a variety of things being used. Bridge condition, like general condition ratings and grouping ratings into good, fair, poor. People were doing that. Bridge program measures are things like how many projects are led, are projects being completed on time and on budget, so there are performance measures there. How many bridges are functionally obsolete, what bridges are imposing weight restrictions, not necessarily posting, but is there a route that an owner would like to pass overweight permit loads on, but they can't because a bridge is meeting legal loads, but they want it stronger than that. That becomes a weight restriction. Maintenance and operations measures, same thing. How quickly are jobs being completed? Structural deficiency, you know, how much deck area is deficient, a measure that many owners used, and then sufficiency rating. So the two areas that are highlighted, bridge condition and structural deficiency, those are the ones that many bridge owners were using and found advantageous to track. Then, of course, there's the national performance management measures proposed in a rule by FHWA. These are basically condition-related or condition-derived performance measures. So how many bridges are good, how many bridges are poor, in terms of deck area and in terms of the NBI general condition ratings. So for performance, we could see three ways to approach performance of preservation. One is just to look at the inventory. If bridges are good or fair, then they should be preserved, and maybe they are being preserved. The idea of looking at the inventory of bridges and their current condition speaks to the part of the AASHTO definition that says let's keep bridges in good condition. We could look at deterioration, how rapidly are bridges deteriorating, and here we're tracking structures moving through their life and through their various condition ratings. And if we're able to slow those transitions, then we're extending bridge life, so we try to get a measure there. And then risk. We look at certain elements that we would count on to be protective, like coatings and wearing surfaces, and if those protective elements are deteriorating, but the major element below is still in good condition, then that's something that should be addressed. There's a preservation opportunity. So we could track how often a good primary element is at risk because of the loss of a protective element or deterioration of a protective element. So the first was inventory, and we had a paper back in 2013 dealing with this. We worked with NBI general condition ratings and looked at the state of Colorado in particular, and we asked, well, how many bridges are in good or fair condition? This would be NBI general condition rating above 5. And to get that, we look at the 3 condition ratings that a bridge has, and we take the lowest one as being the score for the bridge. So we could identify how many bridges were preservable, at least based on condition. That was pretty high in Colorado, 93%. We took a deterioration model then and said, great, how many of these bridges might deteriorate into poor condition, condition rating 4, annually? So we can get a count of bridges. That becomes our preservation need. So we can get a count of bridges, also a deck area. We could identify particular types of decks, like whether they have epoxy bars and so forth. We could look at how many joints are deteriorating to poor condition. The preservation need is something that an owner would want to do. You want to keep up with this need to keep the bridges preserved. We've got need expressed as physical quantities here, but we could attach unit costs to these and say, well, there are budget needs. So we could be offering values for what amount of money, what funding should be put forward for preservation to keep up. Then our preservation impact was, how are the general condition ratings affected? Not a whole lot, right? You preserve bridges, they tend to be fair as an outcome, not good necessarily. And then in particular, how are we moving bridges at or better than general condition rating 6, at or better than general condition rating 5. So here's a look at inventory. It gives us an idea of how well we're doing in preservation. But there's an issue there. If an owner is doing no preservation at all, they're going to have a certain portion of the inventory that's good or fair. Right? They're building new bridges, so those are good for a while, then fair for a while, and then they become poor. So simply having a certain population level of good bridges doesn't tell us that you're preserving them. So we started looking at the movement of bridges through their life. So here we've got, these are Western states, the states are named, but these are the states in the Western Bridge Preservation Partnership, so we put together their NBI data. And we've got the distribution by deck area of bridges in various general condition ratings. And there's a big bulge at rating 7, rating 6. There always is. There's an interpretation that we all stick on that kind of a population distribution. Bridges start out new and wind up old and poor condition. So they must be moving through these condition states through time. And so we take the relative levels of population and interpret them as residents in time of residence in general condition ratings. And so you get a deterioration curve shown here, kind of rapid from 9 down to 8, slowing down for a while in the middle ratings, and then becoming rapid again. Well, we looked at that a little more closely. We took individual life histories of bridges and looked for transitions that we could tell were not being interrupted by maintenance. Transitions from a condition state to a higher condition state, something was being done to that bridge to improve it, apart from just inspectors not agreeing on a rating. So we were looking for complete sojourns in condition ratings where a bridge entered by dropping to a lower rating and left by dropping to a still lower rating. That gave us a very different deterioration model. That's the red curve here. It's not straight. It looks awfully straight in that graph, but it's not quite. But it's much more rapid than the curve we'd get just by looking at the population with its bulge of bridges in good or fair condition. So the blue population is what we've really got. The red population is an estimate of what we would have, what a set of owners would have if they completely stopped their bridge maintenance. So fairly direct and more rapid movement of bridges from good condition down to poor condition. So we visualize here 2 ways that bridges might move through their service life. It's up to the owner which it takes. Either a bridge is put in service at condition rating 9, and it serves for a period of years, 50, 60 years, it gets to 4, and it's taken out and replaced. Or the bridge gets down to condition rating 6 or 5, and of course, there's an intervention. We rehab the deck, we do other things to put the bridge back in better condition, so there's a preservation loop. Maybe once, maybe more than once, but after the preservation loop, the bridge eventually is allowed to deteriorate to 4 and is replaced. So we could look at how the inventory here of deck area in million square feet should be moving through the condition ratings. This is the estimated version with no preservation activities going on. And about 10 million square feet of deck area should be moving from one condition state to the next among the western states, right? What we really see, if we track what's happening year to year in movement of quantities of bridges, is something quite different. We see big movements of deck area from 7 to 6 and 6 to 5, and we see lesser movement out to the poorer condition ratings. Well, this deck area of bridges is not accumulating anywhere. It's leaving condition states higher up than 4. It's being adjusted by preservation actions. So we're able to identify a whole set of flows. So the red arrows down the bottom, there's a certain inventory of bridges that are being taken out and replaced, and so we're tracking those by deck area, and we can see them reappearing at the very highest condition ratings. We can see other exits from condition states at 6 and at 5, but those bridges aren't being replaced, they're being improved. They're being preserved. Right? They're being moved to somewhat better condition by maintenance and repairs. So we do see the two cycles. So we propose a fraction alpha of bridges that are in fair condition now. Are they being allowed to go to poor condition and they'll become replacement candidates? Or are they being preserved first? And so of all the bridges that need to be dealt with in the fair condition, what fraction is being preserved? And that becomes our alpha fraction. So alpha 0 is no preservation. Alpha 1 is every last bridge is preserved. Nothing's allowed to go to poor condition. And we looked at how that compared to the National Performance Management measures. If you keep repairing a bridge and never allow it to get to a condition where it should be replaced, you could have infinite life if you keep fixing it. So the life can get very, very high as alpha increases. The percentage of bridges in poor condition goes down as more preservation is performed. So higher alpha is fewer poor bridges, and that's one of the National Performance Management measures. But higher alpha is also fewer good bridges. If you fix bridges, they're fair as an outcome. You want really good bridges, you should be building new ones. So one of the targets that bridge owners have to set for the federal rule is what's going to be your percentage of good bridges. You've got to be careful with that. If you set it too high, preservation won't serve that end. You need some moderate target. The other thing we look at here, we see the scale for life of the bridge. You've got 150 years there as the top end of the scale, and the curves go off. Mathematically, you can make these things last forever. I mean, that's all modeling and estimates. What bridge do you want? Do you really want 150-year-old bridges as the bulk of your population, or 100-year-old bridges as the bulk of your population? Would you want bridges that were built in 1916 as most of the bridges you own today? So there are other considerations have to come in. Function of the bridge, increases in traffic weight, increases in load. So there's probably some moderate target life for a bridge, which would also influence an owner's choice for alpha and choice for national performance management measures. Then we looked at risk. So wearing surfaces should protect decks. Coating should protect steel beams in this case. Joints should protect everything below them that the water can hit. And so we could compare the conditions, element level conditions of these protective elements to their primary elements and see whether the primary elements are being preserved adequately. There are 4 outcomes here. So here we've got these groups, that's the way AASHTO names them, National Bridge Elements, NBEs, and Bridge Management Elements, BMEs. So the NBEs are the elements we want to preserve. So there are 2 categories there, good condition and poor condition. We're taking the 1, 2, 3, 4s, and 1 and 2 are good for the purpose of this evaluation, 3 and 4 are poor. And so we can put our element quantities there. For the BMEs, same thing. A bridge management element can be in good condition or poor condition. If we're looking at the relation between NBE conditions and BME conditions, we get a space with 4 outcomes. We could have good primary, good protection, good primary, poor protection, poor primary, but the BME is good. There's actually a fair population like that. And then everything is bad. So poor primary element, poor NBE, poor BME. The measure we propose is a measure of good preservation where the primary element is in good condition and its protection is good. At-risk condition where the primary element is in good condition, but the paint needs to be renewed or the wearing surface needs to be renewed. And then poor condition in the primary element, that needs a repair, and that's probably going to destroy the protective element to put new stuff in there. So I looked at your states. So among the Midwest states, or states in the Midwest Preservation Partnership, how are you doing for condition of wearing surfaces relative to the decks that they protect? Well, there's good preservation for an awful lot of your decks, 93%. There's a small group, 3%, where the deck is currently reported good, but the wearing surface is not. And then a certain amount of your decks are in poor condition. We looked at coatings. The graphs say, well, this is steel, excuse me, I've got a different one with concrete coatings. So how are your coatings doing? Well, good preservation for 83%. The steel beam's in good condition. The coating is also reported in good condition. You've got risk for good condition steel beams at about 10% of those, and then poor condition 7%. We can generalize this. Those previous ones had direct parent-child element relations, but we can compare anything. So let's look at how superstructures are doing relative to joints. So the joints are protecting the superstructure. They're keeping the water off the beam ends primarily. So there's good preservation, good joint plus good superstructure for about 74% of deck area of your bridges. This is all measured by deck area. About 23% of the bridges with good superstructure are at risk because the joint's in poor condition. And then there's actual poor condition in about 3% of the superstructure elements. The most general kind of measure we can get here is to take the whole catalog of AASHTO National Bridge elements and compare them to the whole catalog of bridge management elements, not imposing a parent-child relation. Just if there's a bad joint on a bridge, it could affect basically anything. If there's bad paint on a bridge, it could affect basically anything. Not really in a direct sense, but just in the sense that the bridge is not being preserved. And so the primary elements there are not getting the attention that they need. And so we're seeing in the Midwest about 56% good preservation, which is a pretty good number. At risk, 15%, and then poor condition, 29%. A bridge is put entirely into the poor category if any one of the primary elements turns up as being in poor condition. So we've got three approaches to measuring performance of preservation. We can keep track of the inventory, how many of the bridges are good. We can look at the flow of bridges during their life through the condition states. And how is that flow being interrupted? The bridges are being captured before they go to poor condition. That's preservation. And we can look at the fraction that owners are achieving. And then we could look at where good elements, good primary elements, are being put at risk because of lack of preservation of their protective coatings, joints, and other things like that. So three things that we've tried with the ETG in offering as measures of preservation of bridges. And that's the content of the talk. Thank you.